All right, so we'll be using this formula to differentiate logarithm of any base. So the idea is to use this formula from algebra, change of base for logarithms. So recall, if you have log base a of x, then this can be changed into base e, which is a natural log, by simply writing ln of x over ln of a. So that's the change of base formula from algebra that we're using here. We're also using another fact that from calculus, that if you take the derivative of the natural log of x, this is simply equals to 1 over x. So we know that from before. Putting these two ideas together, we're able to get to this formula. So let me show you one more step. So if I want to take the derivative of, say, log base b of x, well, we don't know how to differentiate that, but we can write it into base e. This would be taking the derivative of, so using this base change of base formula right here, we can say this is ln of x over ln of b. And now, using the properties of differentiation, we know that this can be written 1 over ln of b, that's just a number, so we can pull that outside of our differential operator. So this will be ln of b times the derivative of the function ln of x. And we know ln of x, that's the derivative of that is 1 over x. So this is simply 1 over ln of b times 1 over x. And that's what we got right here. So let me just zoom in a little. And this is what we got right here, 1 over ln of b times x. This is how we get it. Let's try some examples. Let's differentiate this function. So we have log base 2 of 1 minus 3x. We're going to be using the chain rule, but before I'm going to change it to natural log. So this is equivalent to, so this is kind of like your x, this piece right here. So using the change of base formula, this is ln of 1 minus 3x over ln of 2. So that is how you rewrite using base e. And now we can differentiate. So the derivative of f, it's going to be, so I can also write this as 1 over ln of 2, so you can see that's a constant, times ln of 1 minus 3x. So 1 over 2, ln of 2, that's just a constant. So this is 1 over ln of 2 times, now if I differentiate this right here, it's 1 over the input. So this is 1 over 1 minus 3x, again, times the derivative of the inside by using chain rule. So the derivative of the inside, which is this piece right here, derivative of 1 is 0, derivative of negative 3x is negative 3. So therefore, that's our answer. Simplifying it, this is just negative 3 over ln of 2 times 1 minus 3x. So that will be our f prime of this function. So here's the next example. Again, we want to find f prime of this function logarithm of base 10 of square root of x. Now I'm going to rewrite again before we differentiate. So I can rewrite this as log base 10 of x to the power of 1/2. Now here I'm going to be using one of the laws of logarithm to bring this power in front of the logarithm. So this is 1/2 times log base 10 of x. And now I'm going to use the change of base formula to change this to natural log. This would be 1/2 times, you'll have ln of x over ln of 10. So that is our function f of x. And now let's differentiate. So we have f prime of x is equal to, so 1 over 2 and ln of 10, these are all constant. And I'm taking the derivative of only this piece right here, ln of x. And we know derivative of ln of x is 1 over x. And there you go, that's your derivatives. So we can just rearrange. This can be written as 1 over 2 ln of 10 times x. So that will be our derivative of this function. Here's the last example where I want to find y prime of this particular function. So again, we're going to change the base to natural log. So changing it to base e, so I have x times, so I'm only changing this piece right here. So you have ln of sine of x over ln of 4. So that is our function. So just rearranging the terms, this can also be written as 1 over ln of 4 times x times ln of sine of x. So you see here you have to use product rule to differentiate this because this is a function, this is a function, and then within that you will have chain rule. So y prime, it's going to be, so keep tagging along 1 over ln of 4 because that's a constant, and then let's differentiate. So I'm going to call this the first function. Let's call this g. So product rule, we differentiate the first, so derivative of x, that's going to be 1. Keep the second, so that's ln of sine of x. Plus, now you keep the first, differentiate the second. So I differentiate g. So derivative of ln of sine x, that's 1 over sine of x, times the derivative of sine of x, that would be cosine of x. And there you go. That's my derivative using product and chain rule. Now, simplify, rearrange the terms. This is equal to 1 over ln of 4 times all of that. So I can just write this as ln of sine of x plus x times cosine over sine. Well, cosine over sine, that's cotangent. So I can write this as cotangent of x. So this is my final answer for y prime.